morning.
And this week we are featuring adding mixed numbers.
Good fun.
Good fun. And here's our first example.
Okay, so we're taking we want to know what is the sum of 5 and 4/8 and 3 and 5/8, and sum means addition.
Addition, right.
So, I don't know. I think we should maybe replace this with an addition sign, just so we can.
Sounds like a great idea. Now, last week we were talking about adding, or 2 weeks ago we were adding fractions. Now we have mixed numbers. Is it kind of similar, different? What do you think?
Remember that way that you showed me to change a mixed number to a fraction? It was a shortcut.
You multiply the whole number by the denominator.
Right, multiply down this way.
And then you add the numerator.
And then add that. So you do this one first, then that one, and then you put all that over the same denominator.
So if you don't know how to do that, go back to video 1.
So in this one, for instance, if we say 5 times 8, that's 40. And then we add the 4, so you get 44 in the numerator, and you leave 8 in the denominator.
All right, let me try that.
Yeah.
So 3 times 8 plus 5. 3 times 8 is 24, plus 5 is 29. And I keep my denominator, so I also have 8.
All right, now we gotta, I guess we should have written them down here to keep our addition problem kind of together. Wow, those numbers are getting kind of big to just add in your head, aren't they?
Ooh, 44, 29.
73, I think. Is that right?
I think so. So I get 73 over 8. And then should we turn it back into mixed numbers since we started out with mixed numbers?
Yeah, because I'm thinking 8 times 9 is 72.
Okay.
So that must mean that there are 9 eighths. 9
So
8
9
over 8s in that 70.
So we can pull out the whole number 9.
Yeah,
And how many are left then?
then just the one, 73 minus 72. Yeah, that looks right.
That looks great. So 73 over 8 turns into 9 and 1/8, and that is the solution to our addition problem. I have a different way of doing it.
Let me see.
You want to see?
Yeah.
Because we actually don't have to rewrite our numbers as fractions. We can write 5 and 4/8 plus 3 and 5/8. 5 and 3 gives me 8.
Well, you can add them even before you combine them.
Yeah, you can add them all together. And now we have,
So we're going to add the whole numbers to
4.
the fractions separately?
because 4 over 8 plus 5 over 8, I can just add my numerators.
Mm-hmm.
So 4 and 5 gives me 9 over 8. Now you're saying that doesn't look like my answer, because your answer was 9 and 1/8.
Right. But this also looks like an improper fraction, which
Right.
you probably don't want in a mixed
So
number.
8 goes into 9 one time, and I have 1 left over, so my answer also is 9 and 1/8.
Oh, so the 1 that you get out of here, you add on to the 8.
Right. So if I were to rewrite it, it would be 8 and 9/8, which is really the same as 8, 1 more 8 over 8,
Mm-hmm.
and 1 over 8.
I see.
This really becomes a 1. 8 and 1 gives me 9, and 1 over 8.
I like this, Ms. Marino, because you don't have, it seems simpler because we were ending up with, adding 29 and 44. That gets murkier.
The numbers stay more manageable this way.
I like this way. Do we have another one?
We do have example 2, and it says, solve the addition problem below. And we have 1 and 1/7 and 2 and 1/4.
I felt so happy when I saw the last problem because they both had the same denominator, but that's not the case this time.
No, I think this time we might have to make some like denominators. But we were really good at this last week and the week before.
That's true. That's true. And I remember that we, well, should we write it your way first?
Oh, we can
Or do you wanna change the
either way.
fractions?
Why don't we do fractions the first time around, and then we'll try it with the other one after.
Okay. So I'm thinking before I even convert these into fractions, I'll change the fraction that already is here so that they have the same denominator.
We
And then
can
I'll
do that.
multiply by this. So as I recall, we looked at the two denominators and we saw which one was bigger.
Mhm.
And then we started skip counting on that one. So we said 7, 14, 21. These are just
28.
7's multiplication tables. And I think, actually, that 4 will go into 28
It does.
7 times.
Perfect.
So, for this one, we're going to multiply it by 4 over 4. And multiplying across here, we'll get, so I'm just going to rewrite the number here. We'll have 1 and 4 28ths.
Let me ask you something.
Yeah.
We are not going to multiply the 1 by the 4, right? It's just for the fraction part.
I'm just changing the fraction. And since I'm just multiplying by 1, I'm not changing its value. So we don't need to involve the 1, yeah.
We don't involve the 1 because we are not changing the value of the fraction itself. The value of the fraction is still 1 and 1/7. These are exactly the same. We're just changing what it looks like to make it easier for us.
And so this one will multiply by 7 over 7. So we'll get 28 in the denominator again. And the numerator will have 7. That's just changing the fraction. Then we'll put the integer for the mixed number in front of it there. And now I've just rewritten those two mixed numbers as new mixed numbers with matching denominators. So now, wow, your way would be much easier with this one, wouldn't it?
Should we just go for it then?
I think we should, yeah.
Okay.
Because we're just going to be changing that to,
So let me rewrite it under here. I have 1 and 4 over 28 plus 2 and 7 over 28. And I just go right down and add my whole numbers.
so 3 over here.
And then you can add your numerators because our denominators are the same.
Okay, then we'll have 7 plus 4, or 11 in the numerator, over 28. Now, 11 is a prime number, doesn't have any factors besides 1 and 11. 28, and it doesn't go into 28, so I think that fraction is reduced.
I think we have our answer.
Yeah, me too. Excellent.
Very nice.
So
See
I
you guys
think-
next week.
I think your method worked better. I was just
You
going
liked
to say, yeah, because otherwise we would have been getting 56 plus 7. The big number problem would have been even worse with 28.
You know, I always did it your way, 2 hours, turned them into improper fractions, and then I did my addition subtraction. But I really like this because it cuts time down a
Yeah.
lot. It's really a lot quicker, for me a lot easier.
I'm happy to know this.
And see you next week.